For this video, we are switching to Vertex form by hand, and we're going to use the completing the square process. That is the process where you add and then subtract b over 2 quantity squared. So a couple details before we dive into this. The first one is that when we're talking about standard form, which is what we have here, we have y equals ax squared plus bx plus c. And so when we're talking here about the b over 2, in our formula, this 10 here is the b. And so we can match that up to this. When we're talking about switching to vertex form is the form that makes the vertex very obvious. So y equals a, the quantity x minus h squared, and plus k. And in this, the vertex is the ordered pair HK. So, with the completing the square process, the math can be pretty intense if we don't have a 1 as the a. But in our problem, we definitely do have the 1 as the a. For me personally, unless I'm told that I have to do it by hand, if I have anything other than 1 here for the a, I tend to use my calculator to find the vertex and go to the vertex form with the calculator rather than by hand. So the completing the square process comes out of the quadratic formula, or the process actually derives the quadratic formula, so very interrelated. And completing the square refers to a process by which we're going to create a trinomial, something with 3 terms, that will factor to a binomial times itself. So let's get started. We want to first figure out what is b over 2 quantity squared. So in our problem, we've already identified b as 10. So 10 over 2 quantity squared. And you could probably do all that math in your head at once, but I'm going to be very explicit. So this would be 10 divided by 2 is 5 squared, which is 25. The reason why I wrote this out is because we will use the 5 later. And so having it here makes it very obvious. Now, we know that within an equation, if we add something to one side, we typically will add it to the other side to keep the equation balanced. But in our case, we want this y to stay all by itself over here on the left-hand side of the equation, because when I look at vertex form, it's still y equals. So in order to keep the equation balanced, I'm going to both add and subtract the 25. But I'm going to do it very strategically. So y equals x squared plus 10x. And this is where, right in here, I'm going to insert the plus 25. So plus 25. These 3 terms together, the first 2 that came from the formula and the 25 that I inserted, are going to be the 3 terms that will factor. And so we added this 25 because it is the perfect number to make this factor. So then I had before a plus 21. And if I add 25, that's not legitimate math to just add 25. The equation would no longer be the same. So I also have to subtract 25. So the end result of adding 25 and subtracting 25 is adding 0. So I did not change the equation at all. I just changed how it looked. So these first 3 terms form a trinomial. That just means something with 3 terms. And I am going to factor it. So factor is to change it into multiplication. And I'm going to change it into 2 factors. After this part that's in parentheses, I'm just going to do the math here. So I have minus 4. So in here, factors of x squared are x and x. And here I want factors of 25 that add up to 10. So 25 is 5 times 5. And then 5 plus 5 adds up to 10. This 5 that we used is this 5 right here. And so that's why I wrote that out, so that you can see, and that's always the case. So as you go through this process, this number inside the parentheses is the number you're going to factor with. And that's helpful if you're one of those people where factoring's not your strong suit. These two match, matching factors. And so I will rewrite this, x plus 5, that quantity squared, minus 4. And this is vertex form. And that's what I was aiming to do. So in my vertex form, my a value is actually 1, because there's no number out here in front, and those are the ones that it's very easy to do by hand, like we just did. And my vertex, I have to change the sign on the h, so my vertex is negative 5, negative 4. And so you could go to your graphing calculator and graph this original one and find the minimum, which would be this point. Or you could graph our new form here, our vertex form, same exact formula, just a different format. And again, your minimum point would be this negative 5, negative 4 vertex.